Now that we have a basic understanding of some of the properties of these inverse functions, let's go ahead and talk about some more properties and something that we can do for functions that are not one-to-one. Okay, so we know that the inverse function reverses the inputs and the outputs. So if you have an input x and an output y for a function, then the input for the inverse y will give us an output of x. We can use this information to determine what the domain and the range of the inverse function will be. Now, remember, the domain of a function is all of the inputs, and the range of a function is all of the outputs. If we take a look at what I have written here, f of x equals y, we'll see that if y is an output for f, it will be an input for f inverse. That means that the outputs for f will be the same as the inputs for f inverse. And now the outputs for a function, that's called the range. So the range of f is going to be the same as the inputs for f inverse. The inputs of a function is called the domain. Now let's make another observation here. X is an input for f, but it's an output for f inverse. So the inputs for f, that's going to be the same as the outputs for x, not x, of course, the outputs for f inverse. Again, the inputs, that's called the domain. So the domain of f is going to be the same as the outputs for f inverse, and the outputs, that's called the range. So two main observations here. The domain of f is the same as the range of f inverse, and the range of f is the same as the domain of f inverse. So as a practical takeaway, if you know what the domain and range of a function is, then you know what the domain and range of its inverse is. You simply switch them. So if the domain of f of x equals -1, 1, then the range of f inverse is also equal to -1, 1. You don't need to know anything more about the function. As soon as you know the domain of a function, you know the range of its inverse. And if you know the range of a function, then immediately you'll be able to know what the domain of the inverse is. Now that we've talked about domains and ranges of functions, let's continue talking about inverse functions and how we can sometimes modify domains of functions so that when we have a function that's not one-to-one, we can create an inverse. Okay, so for example, the most basic example that I can think of a function which is not one-to-one is the quadratic function. So the quadratic function looks something like this. And I'm not going to draw it exactly here. I'm just going to draw a little sketch. Now, this function is not one-to-one, so you cannot create an inverse of it. Typically, what we do, if we want to talk about an inverse of a function related to f of x, is we'll try to delete part of the function so that it is one-to-one. Now, we don't want to delete too much of the function, so we try to find the minimal amount that we can delete so that we keep a large portion of the function, but erase the problem that it's not one-to-one. So for example, if I take this left side here and I erase it, then I have a function that looks one-to-one. And since it's 1 to 1, I can find the inverse of it. Now, the process of deleting part of this function is called restricting the domain. Let's do an example of finding an inverse of a function with a restricted domain that is a little bit more complicated. So in this problem, we're going to restrict the domain of a quadratic function, x plus 3 squared, so that it is 1 to 1 and non-decreasing. Then we'll find f inverse of x on that domain. The wording of this problem is more complicated than the actual solution. So we're going to do the same thing that I just outlined. We're going to sketch a graph, and then we're going to go ahead and delete part of the graph. We'll list the x values that remain, and then we'll go ahead and find f inverse for those x values. Now, this example is slightly awkward in the sense that what I'd like to do is I'd like to explain the restricting the domain part first. Then I'd like to go to another video to explain how, got a little line there, how it is that we find inverses of functions, and then I'm going to come back to this example to complete it later. Okay, so let's first talk about restricting this domain. So this is a quadratic function, but it's not so simple as the quadratic function that I drew earlier. So how do I know how to restrict this domain? Well, the answer is, if you understand transformations, you understand that x plus 3 squared is a left shift of the graph x squared by 3. So if I wanted to sketch a graph of this without using a calculator, then I would simply sketch the graph of x squared shifted 3 units to the left. So 1, 2, 3. If my graph of x squared looks something like this, and I realize that this is not a perfect depiction of the graph of x squared, but we don't need a perfect depiction. We just need a sketch. So if we move 3 units to the left, then we would have something that looks like this. Now it's asking us to restrict the domain of this function so that it's 1 to 1 and non-decreasing. So what we're going to do is we're going to delete half the graph so that it is 1 to 1. Now, if you delete the right half of the graph, what happens is you have the graph of a function that's decreasing. Remember, a function is decreasing if as the x values go to the right, the y values go down. And that's what's happening with this graph. So instead of deleting the right half, I'll go ahead and delete the left half. And when it's asking to restrict the domain, it's asking you, hey, tell me what the domain is after the deletion. After you make it 1 to 1 by deleting half the graph, what are the x values that remain? And the x values that remain for this graph here is all of the x values that are bigger than or equal to 3. Excuse me, not bigger than or equal to 3, but bigger than or equal to -3. And in interval notation, we can write that as -3, infinity. This -3, infinity is what I would call the restricted domain. So we have restricted the domain so that our remaining function is 1 to 1 and it's non-decreasing. In other words, it's increasing. So we have restricted the domain so that we have a 1 to 1 function, and that 1 to 1 function is non-decreasing. In other words, the y values are going up as the x values go up. This is the point where I'm going to pause the solution. We'll talk a little bit about how to find inverses of functions, and then I'll resume this one.